Yeah, great to be here. So I am going to
Crossover
split.
here.
I am going to talk a little bit about DBT, but I'm also mostly going to talk about biologicals, something that obviously Pam and I have a lot of passion around. We've been doing it for many, many years, and we'll get going. But it's such a small group that if you have any questions, please just interrupt, stop.
We'll keep it
discussion.
casual.
What's that?
We'll keep it casual.
Keep it casual, yeah, please. So, yeah, okay, so about me first, I always like starting talking about my own story before I get into my professional side. Believe it or not, I'm an engineer by training. I'm not an Aggie by training, but and unlike my peers, a lot of people in the crop protection industry particularly, I meet them at events, at conferences, and hey, what do you do? Well, I grew up on a farm. I grew up in Iowa, in Nebraska. I've been on a farm for all my life. That wasn't me. That's not me. I grew up in a big city. I actually grew up in Rome. I was born in India, but I grew up in Rome. And the connection there was my dad worked at the FAO. So there's a little bit of a connection with food as I was growing up as a kid. But I joined ag by choice, right? And I think that's important. I could have done it. I started off building life support equipment, right? I did a lot of med stuff at the beginning. As a young hotshot engineer, I thought of myself in that area. But around 2001, 2002, I was going through a career transition, and my wife and I had just started a family, and I'm thinking, you know what, this is a great time to think about what I want to do for the quote-unquote second half of my life. And the more I thought about it, the more I realized that food is something I care a lot about. I lived in India. I've seen poverty. I've seen malnutrition. India is very different today than it was in the 70s and the 80s. We have now, India has got a food surplus. Back then, it was a shortage. You could see famine on the streets. And my dad worked at the FAO. I grew up in Italy, where food is center of every conversation. So I felt really connected to that. And then with the family and the kids that my wife and I were starting, I wanted to do something meaningful. And it all came back to ag, right? And so my first job in ag was in 2003. I joined Syngenta, and let's talk about that. But my passion really is around, and I believe in this, safe, affordable food, not for California, to be honest, but for the world, right? What can we do to develop technologies that are going to allow us to not have another war around food shortages, right? We were very close to that in Egypt and in Ethiopia in about 10 years ago. And of course, I'm very passionate about my family. So we have 4 kids. We live in Davis, very much part of this community now. We feel we've grown roots here. So I'm not going to put another dot there.
No more dots.
No more dots. Okay, on the professional side, 20 years of senior roles in different ag companies, mostly biologicals, actually all biologicals, I should say.
All.
I've worked at the 2 biggest global multinationals, names that you'll recognize. The story is back in 2003 when I joined Syngenta, we were organized in 8 business units. So I was business unit head of one of those 8. And it was that business unit, it was actually mostly around home care. And so that was, when I did the strategy for that, I said, we gotta get away from pyrethroids and other chemical insecticides. Let's look at organophosphates. Actually, we weren't selling organophosphates at the time. Look at biologicals. We could see that we needed to refresh our portfolio. So ours was the first business that actually looked at biologicals at Syngenta, 2003, 2004 timeframe. And then, John, you already made reference to Bayer and the AgriQuest acquisition. I'll come back to AgriQuest in a second. And then the other role at the multinational, I was global head of marketing for biologicals at Bayer. Spent a lot of time on planes, flying around different countries and different regions. And that's something I don't miss. I love the fact that I don't have elite status of any airline. That was something that I aspired to back then. I did 2 years of 250,000 miles a year. That was too much. Okay, so the 2 startups experiences, AgriQuest. I joined about 2 years, I think, after Pam. Obviously, she founded AgriQuest. There was a change in investors. Pam left, I think, 2000 and what was it, Pam? 10, 12? No.
No. I left in 2006.
6, okay, so I joined 2008, so there was a two years difference. AgriQuest, obviously one of the good stories for this ecosystem, Davis Woodland. And then went to Bayer, and then I came back in 2016 and I've been CEO of BBT since. So experience with multinationals, I've seen the big side of things, the big ag side as well as the startup side. I've been a director of BPIA. BPIA is the Biologicals Product Industry Alliance, where we advocate for these products. We spend a lot of time on Capitol Hill with the EPA, talking about all the great things that biologicals can do for agriculture. And then most recently, I've joined a group called Dunham Trimmer. Dunham Trimmer is a market consultancy started by two individuals, Bill Dunham and Mark Trimmer. It's now grown to about 7 of us, people in 2 people in Europe, 4 of us here in the US, and 1 in Argentina now. And spending a lot of time doing consulting and advising and helping smaller companies on market intelligence and go-to-market strategy around biologicals. So that's the professional side of myself. I'm going to go back and forth a little bit between biologicals and BBT. A few slides on biologicals, so what are they? This is a slide that Dunham Trimmer uses a lot to explain what we're talking about when we talk about ag biologicals. And the easiest way to think about them is these are products that are derived from some natural source, right? So unlike a chemical, small molecule fungicide or synthetic nitrogen, these are products that are coming from a natural origin. It really comes in 2 areas. At the highest level, you can think about them as products that have a control effect. So a cidal effect that will control a fungal disease or a pest. Or now there's some interesting technologies coming around herbicide and weed tolerant, weed control as well. Or they have a physiological effect on the plant itself, a biostimulant effect, which they'll actually help the plant reach its genetic potential, closer to its genetic potential, even in the absence of biotic stresses. So help with abiotic stress, help with nutrient uptakes from the soil, and a variety of other things, turning on certain pathways in plants to help them grow faster and achieve higher yields. So those are called biostimulants. So biocontrols are biostimulants. These are registered by the EPA or other agencies. These today, biostimulant products are registered at the state level. That may change in the future. There's a lot of discussion that's going on right now. And then within the biologicals categories, within the biologicals overall area, you've got different segments, right? So different types of products. You'll have biochemicals, which might be plant extracts or products that are coming from a mineral background, for example, or you may have microbial products that are coming from a fungal spore or a bacteria or even viruses. So those are how biopesticides break out, biochemicals and microbials. Macroorganisms are beneficial insects or predatory mites that will eat smaller pests and therefore mostly greenhouses help control different insect pests. There's a couple of European companies that are very strong in the macroorganism area. And then even in biostimulants, you have the microbial biostimulants and non-microbial. So this is a very busy slide, but at Dunham Trimmer we felt it was really important to define the different segments because there's different drivers that are driving one segment at a faster rate than another.
I've seen that slide used so many times.
Yeah, you probably have, yeah. And one of the things that you'll notice is a lot of growth right now with a lot of cool technology around nutrient use efficiency. There's some really cool tools that are being developed to help reduce the amount of synthetic fertilizers that are used because there's companies that are promoting it's either bacteria or mycorrhiza or other fungi or other microorganisms to help the plant uptake nutrients more efficiently. And then there's a lot of course growth coming in the microbials area still in biocontrols as well. This is probably a slide that Pam has also seen before. It shows the industry evolution. So it's interesting that, does this have a pointer? I'm just going to use my finger as a pointer. it starts in 2019, but if you go all the way back to 2020, so biologicals have been around for a long time, right? And there's a class of insecticides coming from Bacillus thuringiensis, which is used very widely as a foliar insecticide spray to control chewing insects. And the same proteins that species produced were encoded into corn and cotton and now other plants as well as plant incorporated protectants. BT cotton, BT corn, and pretty much all the cotton that's now grown, or all the corn that's now grown, has got the genes from Bacillus thuringiensis inbred into those varieties. That was a lot of the early development for biopesticides, biocontrol agents. But what you're starting seeing here more recently is, as some of the bigger ag companies are getting involved, and then the tier 2 players are getting involved, the growth is continuing at a very rapid pace. So the growth for the use of biologicals on farms is growing at 6 or 7 times the growth of chemicals on the same farms, reaching 12 to 13% compounded annual growth rate pretty consistently the last few years, and expected to grow at that rate moving forward. Today, the biologicals are well north of $10 billion in revenue globally. So that's about, compared to a total chemical pesticide category of about 70 to 80 billion, $75 billion. So you're starting to see now the biologicals are actually taking a significant amount of market share away from chemicals. One of the things that's happening more and more recently, and we actually have several examples where in Brazil, biological products are now making big major inroads into row crops. So traditionally, the use of biologicals has been, limited, if you will, to specialty crops, horticultural crops, and now that's changing. Brazil, in particular, has shown that these products can be used very effectively on soybeans, on sugarcane, and other big row crops. And now in the U.S., that's happening as well. We're seeing a significant amount of penetration into soybeans and corn as well. What's driving this trend for biologicals? Well, there's many factors. I always start by talking about a macro, and this is a busy slide, I apologize, just focus on what I've got circled in red there. The world population keeps increasing, right? So we've got to find ways to keep feeding a growing population. You've probably heard about statistics where we're going to have 10 billion people in a couple of decades. How do we grow the food to feed a growing planet without cutting down more trees, without using more water? Water is obviously agriculture is the biggest use of natural fresh water in the world. So we've got to find a better way to, produce more with less resources, right? So you always start by talking about that overall macroeconomic picture, but then you talk about consumer trends, right? So, we've talked about chemical fertilizer, we've talked about chemical pesticides. Well, we don't like chemicals in our food, right? So, the consumer is asking the farmer to change the way they grow their crops. And it's ironic that the region in the world where that consumer demand is the greatest is actually the region in the world where the regulatory issues to adopt biologicals is the worst, and that's Europe. Right, so these are examples of supermarkets in Europe where they are actually, each of these supermarkets has their own standards on residues of chemicals on their produce that they're marketing, which are more stringent than the regulators are, actually. So these are MRLs. So you start seeing MRLs, maximum residue levels, that are actually lower than what the European Union has established as a safety factor. And they're using that reduced MRL as a way to market to the consumer, right? And that's in response to what the European consumer is asking for. So consumer demand is now it's not only Europe. I'm using them as an example. We see the same thing here in the U.S., We're seeing the same thing in Latin America and in certain Asian countries as well. Governments are getting more and more involved in developing clear regulations for biologicals that are different than chemicals. I think they realize that the same ways that they would test for food safety or human safety or environmental safety on chemicals are not applicable for biologicals. So we're beginning to see, or have seen in the last decades, that it started here in the US, where there's a different regulatory path to get biological products approved than small molecules. Brazil is doing a similar thing and is accelerating the adoption of biologicals because they want to encourage farmers to reduce the amount of chemicals that they're using. Europe has tried that. They're struggling with figuring out how to do it, but they will figure it out in the next few years. And hopefully industry stakeholders are going to help the European regulators figure that out for them. So government support for biologicals is actually increasing around the world as well. And then finally, the science, right? So maybe 20 years ago, you could think about a biological product maybe was not as efficacious as a chemical standard, or the cost in use for the farmer was higher than for the chemicals. For a farmer to use that product, there'd be a penalty. There'd either be a cost penalty or an efficacy penalty, right? I'm talking 20, 25 years ago. With the tools that are now available to the scientists, that gap doesn't exist anymore. The modern day biologicals can match the efficacy of the chemical product. In some cases, it can improve upon it. In other cases, it can be a great partner with it because you're delivering a different mode of action to control the pest for the farmer. So there's the technology and the science has reached a point where these products, the innovation is occurring so quickly that there's no longer okay, we're going to substitute a chemical. Now, in fact, we're bringing new value to a farmer that the chemicals don't even have, and that's going to continue. Synthetic biology, RNAi, there's a lot of innovation that's going to that is not only that's already started, but it's going to continue happening for the biologicals in the next years to come. Okay. Any questions about that before I pivot to BBT? I'll come back to some investment criteria and things like that.
I'm assuming just in general, biologicals are safer than like chemicals, or is that?
So there's no, there hasn't been any example which we've known of any biologicals product that's had an issue, a safety issue. I mean, I could list 50 over here on the chemical side, 0 on the biological side. Okay? For me to say that that it'll never happen or it can't happen is probably inaccurate. But what we know is definitely compared to chemicals, yes, much safer.
Okay.
And that's one of the big selling features, right? But we also know that there are biological products that could, in fact, be quite lethal, right? Okay. So we got to be careful about what we say. So the products that are being marketed in agriculture, 100% safe, 100% track record of safety as well. Okay. Right? But we're not selling anthrax. We're not selling other products that could have a negative effect. All right. So BBT. So BBT is a company. I mean, so I mentioned that I've been doing biologicals for over 20 years, and it's been mostly the traditional. You develop a product. You put it at the same distribution channels that you would a chemical like a Syngenta Bayer would, and you would replace a chemical or you use it alongside a chemical. That's the biological treatment agent itself. I joined BBT because I felt it was different. So not only does BBT have a biological microorganism, right, which could say, in our case, it's a fungicide, but it was also IP around a new delivery system. So traditional products, traditional biologicals, you'd still use the same backpack sprayers or tractor sprayers, or in the case of seed treatments, you'd use the same seed treatment equipment. The use of bees to deliver a product was something unique about this company. That's what brought me to BBT. So in a sense, BBT had, it's the only company today that has the advantage of being an alternative to chemicals, right? So it uses no chemicals, we know zero in what we sell, the solution that we're selling. But also, the BBT system didn't use any water and didn't emit any greenhouse gases, right? So we hit not only one box on the sustainable development goals, but we hit a lot of different boxes, right? BBT takes a biological control agent, and it could be BBT's own agent or it could be somebody else's, right? And delivers it to crops using dispensers that were designed to work with bumblebees as well as with honeybees. Now, and we'll get into reasons as to why that makes sense. The company was working on developing 4 different market segments. So the majority of our focus historically was around bee delivery systems, where we were taking our CR7, that was the abbreviation for our microbial strain, and using bumblebees that, for example, Copra or Biobest, these may be names that you may be familiar with, but if you're not, they're big European, now multinationals that are in the bumblebee pollination business, or using the same honeybees that you would see up and down I-5 that are used to pollinate almonds, or cherries, or blueberries, and use those same beehives to deliver the control agent to the crops to control different pests during flowering time. The other half of the business, which we started the last 3 or 4 years, actually after the first registrations that we got for bee vectoring, were for more traditional applications. Right? So what we realized is that this was a great way to target flowering crops, but we knew that our microbe, our CR7, had a lot of utility in non-flowering crops as well. We developed data, for example, in soybeans that showed it was a very effective seed treatment, but we're not going to use bee vectoring to deliver a seed treatment to soybeans. So we started marketing or developing data around seed treatments, and the idea was that we were going to partner that to a bigger seed company or seed treatment company. So the 4 distinct, and then similar for foliar or drench sprays. So we're working on 4 different segments. I'm sorry, I'm flip-flopping back and forth. I should have reversed the order of these. Bee vectoring, coming back to how does bee vectoring work? I think it's kind of cool. I think people probably understand how foliar sprays would work, or how seed treatment sprays would work, seed treatments would work. So I inserted this slide to show how actually bee vectoring works. So what you see here is a bumblebee hive, okay, where you've got probably 300 insects at their peak when it's the most active, and are going out and visiting flowers, because that's the food source. They're bringing protein and sugars back to feed the larva inside the insect. And then what we did is we would place this dispenser on the exit of the beehive, where the biocontrol agent was formulated in a powder, right? So there's the powder, and this white powder here contained our cholestasis. And the bees, as they were exiting, would walk through this powder, formulated in a way that the powder would stick to their legs and their hairs. They would fly with their microbes on them to the crop, and as they visited the flower, as they were pollinating, or as they were looking for their food source, the microbe would fall off their bodies, would colonize the flower tissue, and thereby provide the plant protection properties that the farmer was making. Bees, in the meantime, would return to the beehive, and would decide to repeat itself throughout that blooming season. So the reason this makes a lot of sense is, yes, there's a lot of crops that require pollination, right? So the markets are, there's almost 3 million beehives that are used in California actually pretty much from now until the end of March, to pollinate 1 million acres odd of almonds. The numbers are there. It's big business, believe me. But from a scientific perspective, it makes a lot of sense as well, because the flower there's a pretty picture of a sunflower over there. It's actually the portal of entry for many pathogens that affect a crop. So if you can get the biological control agent to the flower before the pathogen arrives, you can actually provide very good control against the pathogen. Okay? So from an agronomic perspective, it makes a lot of sense as well. Compared to spraying, during let's say a 6 or 8 week period that almond flower might be in bloom, or the sunflower, or a blueberry, or a strawberry flower would be, a farmer might spray once or twice. So for 3 or 4 weeks, any flower that opens before the next spray is vulnerable. As soon as a flower opens, a bee is going to want to visit it because it's a fresh resource for it. So you can deliver an inoculum right at the very beginning to protect that flowering bloom from the very onset of when it opens up. So agronomically, it's also a very effective way to deliver a biological control agent. And by the way, I keep saying biological control agent, but you could theoretically deliver a chemical this way as well. Right? We choose to deliver biological, but the technology itself, it's agnostic as to which product you're delivering to the crop. The data is great. Yeah.
So the microbial solution is provided to the flower, and it colonizes the flower. Does that then colonize the fruit that the flower creates, whether it's an almond or,
Yes.
eggplant or whatever?
Yes.
Does it also inoculate the rest of the plant, the stems, the leaves?
So our microbe doesn't.
Okay.
Our microbe is, we call it kind of locally endophytic, meaning it stays within the flowering tissue and the fruit.
And the fruit that's
It doesn't move up and down the plant, right? It's not truly systemic, it doesn't move up and down. There's other products that you could deliver that could be.
So your specific microbe
Yeah, ours
stays
doesn't.
local, but there are other microbes that could be delivered through bees that would
100%.
actually
100%.
inoculate the whole plant.
100%,
Got it.
yes. The data with our CR7 is compelling. So here is data from, this was captured in 2020, when we were kind of at our peak. I talked about that. The company's very different today than it was a few years ago. There are 40 or so growers in the Pacific Northwest that were using the product. So this was a histogram showing data that we collected from not all of the growers, but a handful of those growers. So what you see here, the brown line shows the distribution of size of berries using your traditional. So all blueberries pretty much use bees as pollinators, right? So what you're looking at is bees only compared to green line, which is bees with the CR7 being delivered, right? So that's the difference between the brown and the green distribution. So what you see here, immediately here is the effect of the CR7, where you're actually, we know that our product also has a plant health element to it, where you're making the berries bigger, right? You're making the weight, the distribution of the pack that the farmer's selling heavier, which means more jumbo packs for the farmer, higher price that they could get for the crop. It translates to about a 40 times return on investment based on what our pricing was. So the data is amazing, right? We've seen not only that the system can control the disease, but it can improve the quality of the crop as well. And in addition to controlling fungal pathogens using our CR7, we were heading down a journey where we were testing the product with other people's products, other third-party products, to control other pests that affect the crop at the flowering time. So the idea was that you could have 2 or 3 microbes in that same white powder that the bees would deliver. One would control botrytis or Olinia, and the other one would be an entomopathogen. It would control thrips and other insect pests, for example. So that's the business that the company is heading down. All right, that's all I'm going to say about BBT. I'm happy to answer questions. I want to come back to biologicals and talk about the business of biologicals a little bit. Right, so I've talked a little bit about already, how biologicals are now almost $10 billion, or in excess of $10 billion. Relatively slow start until early 2000s. And one of the things that you started seeing in early 2000s, it was the European multinationals, right? So BASF, Bayer, and Syngenta made acquisitions, and ironically, it was all in 2012. I think BASF.
High price of corn.
High price of corn. So it was BASF bought Becker Underwood, right, which is a big seed treatment company. Bayer bought AgriQuest, which was a play in a broad variety of crops. Syngenta bought Pasturia, which was more nematicide, so they started slower. But it's all these guys that basically saw the writing on the wall, that their chemical portfolio was gonna come under scrutiny, under challenge. The drivers I talked about and how Europe was further along than the US was. It is interesting to see that these companies that actually started first. And Corteva is there now, but they weren't there back in 2012. DuPont, of course, they were DuPont and Dow back then. What we're seeing in the last 5 or 6 years, maybe the last decade, is all the next tier of companies have also come into it. So here's Corteva, right? So now this is the big four. Now they've got a $200 million biologicals business, probably a little greater than that. They're in a big way, not biocontrol, they're mostly in the biostimulant space. Of course, you've got traditional companies like BioVest and Corporate that were always biological focused. But then you've got the next tier, FMC, UPL, these are all, now multi-billion-dollar global multinationals. And what you started seeing recently is also because of the promise around biologicals having an impact even on chemical fertilizers. Companies like Yara and ICL, which are fertilizer companies, are also getting into the biological space to make combinations to make their nutrient use more efficient. So it's creating this new energy, it's bringing more credibility, more investment dollars into biologicals. Yeah, sounds like the last part there. What we're seeing more and more now is how chemicals, biologicals are being used in combination with chemicals. So, a few years ago, you could have thought about mostly chemicals used on farm, the mostly intensive chemical programs that a farmer would use. But today, it's mostly integrated. I mean, these products are being used. You spray one product one day, you'll spray a biological the next day, and you'll come back and do a chemical, and then you'll go back and do a biological, or you do tank mixes, you spray them at the same time. That's the name of the game, because you're bringing different modes of action, you're bringing different ways to help the crop fight diseases or grow healthier. Here's another example. I like using this a lot to show how biologicals can help in a program. If you haven't seen these kinds of graphs, you're basically looking at, over time, the development. So think about this, whatever, mustard colored line first. Development of the disease, how it increases, right? With the absence of any pest control products, right? So this is a grape grower in Washington. The disease that they were looking at for that is powdery mildew. So that's the untreated. These are two of the programs that were tested. The blue line is the standard chemical program. So there were 7 chemical sprays at, you can see them here, timing A, B, C, D, E, F, right? You were spraying the chemical program. And then that compared against a program where 2 of those chemical sprays were substituted with a biological spray. A product that Pam and I are both very familiar with. And at timing, I don't know which, okay, here we go. At that number 5 and number 7 sprays were biological sprays. Now, if you were to stop right there, and I believe me, I face this day in, day out at Bayer. I would stop there and I would go show my Bayer colleagues, or actually a colleague of mine would show our Bayer colleagues, that, oh, you see what, why don't we start selling the biological? It's just as good, right? They said, no, Mr. Malik, because the control is coming from the 5 chemical sprays.
Oh,
Your 2 biological
hate
sprays
that.
aren't doing anything. So then we got smart. We said, okay, now this is the wrong way to do the field trials. We introduced a new spray where we actually had blanks. So at those 2 timings, we did not spray the biological. So you're now comparing a 7 chemical spray against a 5+2 spray against a 5 spray. And you could see that the disease comes back when you have only 5 chemicals.
Oh, that's clever, yeah.
So you actually, in fact, show the incremental value of the biological from the, and this is how
That's
you have
great.
to retrain
Yeah.
a big company like Bayer that's been used to doing trials in a certain way to deliver the data that could then allow their sales guys to go sell it. And then of course, there's a whole bunch of other benefits from these programs because the chemical residues are much lower as well, right? So this shows how these products can be positioned now in programs. Now, this is a slide that's probably 10 years old.
Yeah.
Everybody's doing this kind of work
Yeah.
now. That's what's exciting. Yeah, and again, in modern agriculture systems now, the name of the game is how do you optimize productivity? It's all about how do you get a crop to boost its genetic potential. So we're seeing biologicals that are used as biofertilizers, and 90% of soybeans that are grown in Brazil and about 50% of the soybeans that are grown here in the US have biological inoculants to help the legume, the crop, fix nitrogen from the air. Very common practice as a biofertilizer. We see biostimulants being used to help, other plants fight abiotic stresses. These are water or salt, water drought in this case, or excess salt, and help to fight the plants to grow in those environments, in those soils. Or of course, we've talked a lot about biocontrols as well. So we're seeing biologicals that are used throughout the crop production system. Because of the recent developments, the last 5-6 years of not only the multinationals getting in, but the tier 2 companies getting in, they're great, and none of them have rich biological portfolios. So startups now obviously see these big ag companies as potential business partners of theirs. So there's a very, very, very active ecosystem of innovation around biologicals. And this is a chart that a group produces once a year to basically, and this I think represents, 1/10 of the number of companies that are in the space. I think at last count, I heard there were about 1,000 startups in biologicals alone, developing different types of products for ag inputs. Yeah, and then this is the last slide to actually show you the dollars and the deals that are being done. So we've started Dun & Triple. We track the number of partnerships or investments or exits that are happening in the biological space. Smaller companies being bought by larger ones, or 2 larger companies doing a joint venture. And you start seeing, there was a slight dip around COVID time, but the numbers are back up to about 80 or 90 a year rather. Deals that are being done. So it's a very active space. I think it's going to continue to be a very active space, at least for the next 10 years, because of some of the new technologies that are being developed that are going to ultimately have to be commercialized. All the big ag companies now have venture arms that are investing in startups. So there's fresh money that's coming in as well. Sometimes it comes with strings attached, other times they don't have any strings attached, but it's something that we track and are seeing a very healthy, the last 2 years have been hard in agriculture, but biologicals are still getting a lot of attention. That was the last one. And on a upbeat.
Ashish, I noted in your last slide, even though the top line number was large, the actual amount of investments seem to be reduced.
Yeah, because I think you're seeing the COVID effect, and you're seeing what's happened in ag markets the last 2 years, right? There's been excess product in the channel. I mean, was it yesterday or this morning? FMC announced, and FMC's
very bad results.
Number 5, number 6, they announced, yeah.
And Corteva's were bad.
Corteva's were bad. FMC stock got a 34% hit.
Crazy.
So I think you see, and even though revenue may have been off by 5%, right? It's not a huge number. And but you're seeing excess, and you have seen excess inventory in the channel. In 2021, 2022, there was a lot of product that was pushed into the channel, and for some reason it hasn't been moved out, and so everybody's missed their sales numbers. And I think because of that, there's been a little bit less investment, but it's going to pick up, John. I mean, I can go back and I can show you a slide. Every 7 years, this happens. So we're in it right now. It'll probably last another year, and then it's going to pick back up.
Yes,
in terms of the total dollars.
2018 was the high point
Yeah.
for
Yeah.
M&A,
Yeah.
joint venture
Yeah.
investments.
And I think here you had a COVID impact,
Yeah.
and then I think here you've got the ag cycle impact.
Yeah, good prices of commodities and low interest rates, in that 2021 and 22 timeframe. Yeah.
Yeah.
Is there more optimism for adoption of these types of controls compared to other technologies where the public perception, even though it's a great technology and everything checks off, there's, you sometimes get up right to the finish line and then somebody jumps in and sideswipes it?
So
Is it-
I think there's always so biologicals, because they come from a natural
Yeah.
origin, do have favorable regulatory pathways.
Yeah.
Certainly in the US, it's well understood, well established. Europe, it's not yet, but it will be. Brazil, it's very well understood and well established. And I think that the advantage that biologicals have over chemicals will continue. But they are getting more and more stringent, right? So the gap will still be there, but to get a biological to market now is harder than it was 10 years ago. There's more data that people have to provide. The jury's still out a little bit, in my opinion, around technologies like gene-edited microbes.
Yeah.
The technology, you can engineer a microbe and put it on the micro, and the scientists will tell you they're 100% safe, right? But it's the same issue that GMO crops face. There's this perception that you're playing God, you're changing, you're artificially creating a bacteria, right? And so how is that gonna get regulated? I don't know.
Yeah,
It
they
is-
were deal with CRISPR technologies.
Yeah, exactly. I mean,
Yeah.
today the scientists can do amazing things
Yeah.
using CRISPR.
Yeah.
Yeah. Now, there are companies that'll engineer a microbe
Yeah.
and then harvest the metabolites and the compounds that the
Yeah.
microbe produces, and then they kill the microbe, so you're not putting out the microbe. Because the concern there is you're putting out a genetically modified microbe out in the field, and God knows what's gonna happen, right? So, you know, you can kill the microbe either deliberately or because it's not viable, and just
But like
sell the
Switch
compounds.
Bioworks is engineering microbes, just got 17 million.
Yeah, they just did a big
And
one.
Robigo, 10 million, so,
So I think for the US, I think you'll be able to get it to market.
You think so?
No issues. Yeah, I think so. Yeah.
not Europe at all, though, no.
Europe, I don't know.
No.
I mean-
Gene edited maybe, but not GMO.
Not GMO, I don't think so. You know, it's interesting because I talked about, you know, my role at BPIA, and I would spend a lot of time on Capitol Hill talking to legislators. And it would often be about, you know, you're advocating for these products, and I remember sitting down, I don't remember who the gentleman was, but, and the conversation was just around that, and I asked him, what if I came to you and I had an engineer microbe, and I had a gene edited microbe that's putting out the market? How would you feel about it? And this guy was from Kansas, and his answer was, well, as long as it's providing value for my farmers and
Yeah,
you can show
yeah.
it's safe, I'll support it.
Yeah.
So I think there is a path to get those products to market in the US.
Yeah, well, there's a framework now, at EPA, so,
Yeah.
yeah,
Yeah, but you may have, you sort of get public perception
yeah.
issues.
They're always
But-
gonna be there,
They're always
so
gonna be there. But, you know,
you're always
the-
gonna have to fight
Well,
it.
Pivot has
You-
done okay with gene edited.
Yeah,
There's
yeah.
no brouhaha about that one.
Yeah.
You know.
You know, the funny thing is, how is insulin produced? Engineered microbes,
Yeah.
right? How are enzymes that go into your laundry detergent produced? Engineered microbes. So, you know, it's funny when people think about those same types of technologies used on food. It's like, oh my God, you can't do that, but I'm happy to inject insulin that's produced that way.
Yeah.
I'm happy to wash my clothes. You know, sometimes it just doesn't make sense. But I think as an industry, we're getting smarter about that. Yeah.
Probably figuring out how to go to market with a little more intelligence.
Yeah.
as-
And not using the techniques that, I mean, so GMO crops, I mean, they've been around for 50 years,
Mhm.
totally safe.
Yeah.
But the way Monsanto went about it, they created a lot of enemies. And had they gone about it a different way, I don't think we'd have the same resistance to GMO crops that we do today. Because they just, bulldozed everybody.
Yeah. Thank you.
So net, based on your biological product industry efforts, is it, no clouds in the horizon? It's all upward?
It's all upward. I mean, yeah, sure, the clouds in the horizon. But it's
EPA
also-
cuts?
Yeah, I mean, yes, for 4 years.
EPA staff.
4 years, we don't know where we stand.
Yeah, right.
But Brazil is all upwards.
Brazil's good.
Europe will come around. I think even the US, there'll be a little bit of uncertainty, but that's gonna affect every aspect of ag. If obviously the market gets cut.
You talked about the Americas and Europe, what about Asia?
Yeah, Asia, it's interesting. Asia, it's difficult to say, US is such a big market by itself, right? Brazil is dominant in Latin America. Europe is done as a union. Asia it's really individual countries. So biological products in India, for example, are used commonly. The issue in India is they tend to promote internal, especially microorganisms, ones that are harvested locally. So for a product to get imported into India or exported into India, depending on which side you're looking at it from, is hard. You have to show to the Indian regulatory authorities that microbe is, native in Indian soils. So you got to jump through some extra hoops there. But they're used commonly by the Indian farmer. They're used commonly by the Chinese farmers. They're widely accepted now. They're accepted in Australia, New Zealand, Korea, Japan. So but you got to think about it individual country by country.
Are there indigenous biological companies in India
Oh,
then
yeah,
promoting
a
those
lot.
Indian
Oh, yeah.
solutions?
There's a very active, just like we have BPIA over here,
Yeah.
there are actually 3 competing associations, and I think there's 3, maybe there's 2, that are all trying to get the voice of the Indian regulators. Yeah. And there's a lot of Indian companies now that are exporting into not only US, but also Europe. And I go, Pam, she and I go to conferences in Europe every year in September and October. And this is the biggest international conference for biologicals. I would say half of the companies there are Indian or
Yeah.
Chinese companies.
But the quality of
that
the
are-
product?
Yeah, the quality is not as good as the ones you find over here. But what they're trying to do is find distribution channels into Europe or North America. There's some Indian companies that are doing well now. In fact, there was one that just made a big acquisition of Plant Healthcare, that PI Industries, that they're a company to watch out for. They're gonna do some big things.
Are your slides available online anywhere? I mean, they're very good. So
They're great slides, yeah.
I pulled together 3 different presentations,
Okay.
but I mean, I don't have a problem.
You should post it on your LinkedIn pages as a resource.
Yeah.
They're good slides, yeah, very good slides.
Yep. I'll do that, figure it out.
Thank you, appreciate it.